Hey guys, so I tried doing this earlier, but there was just way too much going on. So I'm going to give it a shot now. Um, this is going to be the crystal ball for chapter 3, and we've got 20 different questions, and you need to be able to do all of these things. So let's take a look at 3.1. Okay, so 3.1, it says begin by graphing f of x equals 2 to the x. Now, you're not going to have to do that, but you can, but you can also use the graphing calculator. So using the graphing calculator, you go to y equals, and then you have 2 raise it to the power of x, okay? And so that would be your parent function. And then we are going to do number 30. So I have 2 raised to the power of the x plus 2, close parentheses, and then minus 1. Now I want to differentiate between which graph I'm seeing, because if I don't pay attention, I won't know which one's first and which one's second. So I arrowed over to the far left, and I'm going to hit enter until that's a thick line. So now I have the thin line for the parent function and the thick line for the transformed function. So now I'm going to graph these. That was the parent, and now this is the transformed one. Okay, so when you are looking at these, you can then go to your table, and we want points from the second one because the first one was the parent one, so this is our transformed one. Now, looking over here, you see I had to go over to x to go up and down. So I don't think I can't, yeah. So you have to go to x to get the different values. So for my parent function, I would have negative 2.25, negative 1.5, 0, 1, 1, 2, and 2, 4. And that is for the y equals 2 to the x. So we could do that using just a regular calculator and then plotting those points, or you can do that using the graphing calculator. And then the y equals 2 to the x plus 2 minus 1. That is going to give me negative 2, 0, negative 1, 1, 0, 3, 1, 7, and then 2, 15. All right, so graphing this, okay, so if I had gone with this one, and then I just saw that the y equals 2 to the x plus 2 minus 1, this plus 2 here tells me I'm going 2 to the left. And this minus 1 tells me I'm going down 1. So I can plot the parent function points, and 1, 2, 3, 4. So these would be my parent functions. And then I can shift everything 2 to the left and then 1 down. So 1, 2, down 1. 1, 2, down 1. 1, 2, down 1. 1, 2, down 1. And then 1, 2, down 1. And this would be my transformed function, okay? Or you could just go directly into using the table, but make sure you copy this down. Negative 2, 0, negative 1, 1, 0, 3, 1, 7, and there you go, okay? All right, so now let's take a look at the y, or the f of x equals e to the x. So for 35 to 46, but I went ahead and just said 35 to 42 because those are going to be, we're not going to have any shrink or stretches on the test. It's going to be one of these. So again, I'm told that my parent function is y equals e to the x, or f of x equals e to the x. So using a calculator, I can easily figure out what the e to the x, or what those values would be. So e to the negative 2 is 0.135. We got negative 1, 0, 1, 2. I know anything raised to 0 is just 1. Raising that to the negative 1 is going to give me 0.368. And then raising it to the first is going to give me 2.72. Raising it to the second is going to give me 7.39. So now these are my parent function points, and I'm going to look at number 39. So for 39, we have h of x equals e to the x minus 1 and then plus 2. So this minus 1 up here tells me I'm going 1 to the right, and this plus 2 here tells me I'm going up 2. So if I were to plot my parent points, I'd have negative 2.135, negative 1, 3.68, 0, 1, 1, 2.72. So then this is that parent function. I'm going 1 to the right, and then I'm going up 2. 1 to the right, and then up 2. 1 to the right, up 2. So now this would be my graph. Okay, so that is going to work, and that would be perfectly fine because I'm seeing these points and I'm told that you are going to the right and up. The alternative to doing it this way is then to put this into the graphing calculator. So we got we've got the e raised to the x minus 1. Don't know why my brain's not wanting to remember that. And then plus 2. And now I'm going to look at the table of values by pressing second and graph. And looking at these points, I have negative 2, 2.04, negative 1, 2.13, 0, 2.37, 1, 3, and 2, 4.7. And then that will give you more than enough justification as to why these points would be here. Okay? All right, so that's 3.1. Now let's go ahead and take a look at 3.2. So 3.2, we have a problem from 1 through 8, which is write each equation in the equivalent exponential form. So looking at this, let's pick, I have no idea. Let's pick number 2, or number 3, sorry. So looking at number 3, I've got 2 equals log base 3 of x, and I'm wanting to put this into exponential form. So I would rewrite this as log base 3 of x equals 2, and then we know it's 3 to whatever this power is equals that x. So this would be 3 squared equals x. Do we have to evaluate it? No, we just have to put it in its equivalent exponential form, and that's it. All right, 9 through 20, you are writing each equation in its equivalent logarithmic form. So now for this one, we are going to take it from exponential and put it into logarithmic. So let's do 14. Okay, so for number 14, cubic root of 64 is 4. So we know this. We know this is a fact. You can put that into the calculator and it's going to be perfectly fine. Okay, but I need to write this as a base raised to a power, and so that's going to be 64 raised to the 1/3 equals 4. And now this is my base my value it's equal to, and then that's the exponent. So we've got log base 64 of 4 equals 1/3. And that would be the answer because you're just writing it in logarithmic form. Okay. All right. Now we are looking at 21 to 42. And this one is evaluate each expression without using a calculator. So we are looking at number, oh boy, I don't remember which ones you guys have done in class. So let's do 31. Okay, so we've got 31 is log base 2 of 1 over square root of 2. So I know the square root of 2 is the same as 2 to the 1/2. So then this is log base 2 of 1 over 2 to the 1/2. But if it's in the denominator, that means I need to raise it to the power, or move it to the numerator, and I do that by changing the sign. So this becomes log base 2 of 2 to the negative 1/2. Now this is in logarithmic form, and I want to know what this is equal to, so I'm going to go ahead and put it into exponential form. So I have 2 to the x equals 2 to the negative 1/2. And since these have the same bases, then I know the exponents are equal. So then x equals negative 1/2. And that would be the answer for that one. Okay, now we're looking at 47 to 52 from 3-2. And this one is going to be, on the test, it is going to be a graph with the parent function given, and you have to then match the graph with the given, or with an equation. Okay, so if this is my parent function, so this is the parent function down here, and I want to know which graph, so if this is h of, if this is f of x equals log base 3 of x, and I want to know which graph is h of x equals log base 3 of x minus 1. That minus 1 is telling me to go down 1. So I'm going to look for the graph that was here, and now it's telling me to go down 1. So it's not this one because that one went to the right one. It could be this one. I was at 3-0, and now this one is, or sorry, 3-1, and now it's at 3-0. That's the only one that matches, so it's got to be 49. Okay, and it's simply by looking at, hey, that went down 1 unit there. Okay. For 75 through 80, it says find the domain of the logarithmic function. So the one that you guys are going to be looking at is going to look like 75 to 78. So we've got 77. The 2 minus x has to be greater than 0. It cannot be equal to 0, and it cannot be negative. So you take whatever you have here, and you set that greater than 0 and solve for x. So I'm going to add x to both sides here, and I have 2 is greater than x, or x is less than 2. And that would be the answer for number 77. Okay. All right. So that's it from 3-2. Now let's go ahead and take a look at 3-3. And from 3-3, we have in exercises 1 through 40, use the properties of logarithms to expand each expression as much as possible. And I'm going to press pause for a second. Okay, so I tried to stop the bell from getting on there, but I think we're going to catch it on the second one because I don't have time to wait. Okay, so now we're looking at 1 through 40 from 3-3, and there's going to be 4 different ones from this section. So it's all just expanding the logarithmic expression as much as possible. Remember that you have log of b of mn is equal to log b of m plus log b of n. Log base b of m divided by n is log base b of m minus log base b of n. And finally, log base b of m to the n is equal to n log base b of m. Okay, so those are the three properties that we are using, and we're going from the condensed version to the expanded, and then we're going to go the other direction. Looking at number 14, so we've got ln of e to the fourth over 8. All right, so I'm going to separate the division first using the quotient property. So then I've got ln e to the fourth minus ln of 8. Okay, this 4 is going to come out front. So you have 4 ln e minus ln 8. Ln e is the same as 1. So we have 4 times 1, which is 4, minus ln 8. And that would be the answer. 23. Log base 4 of square root of x over 64. Okay, so looking at this one, this is the same as log base 4 of x to the 1/2 over 64. So I am going to begin by using the quotient property again. So then I've got log base 4 of x to the 1/2 minus log base 4 of 64. This 1/2 is going to come out front. So I have 1/2 log base 4 of x minus log base 4 of 64. Okay, this can be simplified. They're not always going to be able to be simplified, but this one I can because I know 64 is 4 cubed. So 4 to the third power equals 64. So then that means this is replaced with 3. So I have 1/2 log base 4 of x minus 3, and that would be the answer. Okay, all right. Looking at 41 to 70, these we are condensing them, so we are going in the opposite direction. Looking at 54. So for 54, we've got 5 log base b of x plus 6 log base b of y. And we are going to go ahead and use the power property first. So then you've got log base b of x to the 5th plus log base b of y to the 6th. This addition tells us to use the product property. So then we have log base b of x to the 5th, y to the 6th. And then that would be your answer. Let's do 64. 1/3 log base 4 of x minus log base 4 of y. All right, so I'm going to do the stuff on the inside of the parentheses first. So that means I'm going to address that quotient. So then I have 1/3 times log base 4 of x divided by y. Now this is the product, the power. So that's going to go up here. And we have log base 4 of x over y raised to the 1/3. This can then be written as a cubic root. Now this is not going to be in proper form because we would rationalize that y if we were going to leave this in simplest form. But it just said to condense it. so here we are, okay? Now we are looking at the 71 to 78, and these are using the common logarithm or natural logs to evaluate to 4 decimal places. So this one, you are simply putting it into the calculator, but not just simply. My apologies, we have to use the change base. So let me look at number 74. So 74, I have log base 16 at 57.2. There is no way on this calculator or on this calculator that we can change that base of the log. And even if you have one of those calculators, you still have to show me this work to get the full credit. If I don't see this work, then you don't get the full credit. If I see just an answer, that's only worth half of the credit. So then this is going to be log of 57.2 divided by log of 16. So then we've got log of 57.2 and divide that by log of 16. And that's going to give me 1.459. Oh, it said to the 4th place value. So 1.4595, and that would be the answer. Okay. Now we could have also done that using the natural log. So natural log 57.2 and then divide that by natural log of 16. And that gives you the 1.4948. So it doesn't matter which one you use as long as you are consistent in using natural log for both of them or log for both of them. Okay, now we are looking at 3.4. For 3.4, we are looking at the 23 to 48 section, and I actually cut it off at 42. And even with that, I'm not sure if that was the best cut or not, but we're going to leave it there. There are 2 problems that are similar to this type of homework problem. Let's take a look at number, let's take a look at number 35. Oh, you guys did the multiples of 3 on this, so anything that's not a multiple of 3 you haven't seen. All right, let's do 40. So then we've got number 40 is 3 raised to the x 7ths equals 0.2. Oh, that's this one. All right, so this is in exponential form. So that means I'm going to either put it into logarithmic or natural log. So I'm going to go ahead and do log base 3 of 0.2 is equal to x over 7. Now I can use the change of base, so log of 0.2 over log of 3 equals x over 7. I need to get the x alone, so I'm going to multiply both sides by 7. So then that gives me 7 log, where'd it go? Okay, 7 log 0.2. I'm going to hit enter and then divide by log 3. And that's negative 10.255. So x equals negative 10.255. I forget where it said to round, so I'm just going to round it to the thousandths and be done with it. Looking at 49 to 66. So 49 to 66, we are given the problem in logarithmic form and need to solve it. So that means we're going to put it into exponential form. Looking at number 58. Okay, so if I do 58, I've got log base 7 of x plus 2 equals negative 2. Okay, So this is in logarithmic form. I am going to put this into exponential form. So 7 raised to the negative 2 is equal to x plus 2. Okay, so 7 raised to the negative 2 is the same as 1 over 49, which is the same as 0.0204. And that equals x plus 2. So then we subtract 2 from both sides, and I get negative 1.98. And that would be the answer. 67 to 90 is going to be on this part, okay? And then we had the ones where we were putting them together. Okay, so looking at 79, let's do 79. So I've got log of 3x minus 3 equals log x plus 1 plus log 4. Okay, so I am going to use the product property. So then I have log 3x minus 3 equals log 4 times the expression x plus 1. These are the same, so that means these expressions are equal. So I have 3x minus 3 equals 4x plus 4. And now I just solve for x. So we're going to subtract 3x from both sides and subtract 4 from both sides. All right, so I have x equals negative 7. Okay, so if I go and put this in up here, negative 7 plus 1 is going to give me negative 6. That's not going to work. Negative 7 times 3 is negative 21. That's not going to work. So this one, I picked the only one that does not have a solution. So this one has no solution set. Good times, right? Okay. But that's what it is. We just work it out and then check and make sure that they work. And in this case, this one did not work. All right, the last thing that I wanted to look at with you guys is from 3.5. The exponential models describe the population of the indicated country. This one, what is the population of Japan in 2020? Okay, so this says years after 2020. So that means that the time is 0. 0 years have passed. So then looking at Japan, I would have A equals 126.5, E raised to negative 0.003 times 0. This is going to give me 0. Anything raised to the 0 power is 1. So then I would have 126.5 million people in Japan in 2020. All right, so it's under 30 minutes. I apologize it took that long. I really did try to keep it short, but I know I talked too much. Okay, if you have any questions, email me, and I will see you guys later.